So yeah, thank you to everyone who's here, and thank you to NACIS for having me. This is my presentation on sort of the advantages and disadvantages associated with using tilesets, and maybe some tips that you can apply to your own styles to avoid some of the pitfalls of those, and some tips that I've been using in my work at the New York Times to make our stories a bit more performant and easier to digest. So why tilesets? It's quite clear. They're instrumental in web cartography. As a Canadian, this really hurt to pull this up and see that like Hudson Bay gets a icon. I don't know. But it's really enabled us to do these incredible visualizations that wouldn't have been possible. To interact with something like this so seamlessly on the web is just incredible. And this other visualization from the pudding, being able to do this like 2.5 dimension extruding of this data, the global data set that you can zoom in and get higher quality data is just great. And in tilesets, you can also throw thousands of points into them, apply a hierarchy, and naturally get this like ability to zoom really into this really detailed data. So why not tilesets? It's usually because of things like this. Half-loaded tiles, these are from all sorts of map providers. But I find that they really pull you out of a story, especially like if you're really deep into a narrative and you just are waiting for like tiles to load, or you see like a loading circle or something. So avoiding that at all costs is I think, really important to a really good data viz. And this, I think, this is what I see as an ideal interactive web map. This was a New York Times article from years before I joined, but I looked to it as a source of inspiration because with each gesture of scrolling, you sort of get new data revealed to you. You get the scope of how climate change is affecting Yellowstone National Park, and it just works so seamlessly, and you never are waiting for anything to render or to load, and yeah, I think it's fantastic. So why do tilesets have this issue with rendering? Usually when you take a base map, you're inheriting all the things that are in it. So you might be getting way more data than you actually need for the scope of your project. So this is showing like the collision detection of labels in a standard base map. And you can see, if you were just focusing on maybe a European scale data set, you wouldn't actually require all the data that's built into that tile set. And by being able to filter and strip back the data in the tile, you'll actually end up with a much more performant data visualization. Sprites are another thing that you shouldn't just take the sprite sheet that's given to you. There's ways of editing sprite sheets. This is from like one of here's default maps. If you are never zooming into point of interest labels, this entire sprite sheet here on the left, or on the right, you don't actually need. And then highway shields, maybe you don't need that level of detail. You could just have a circle to represent each of them. So this is 0.5 MB that you could clean up. And that's exactly what we do, or what I've done at the New York Times. We have an earthquake tracker, and we really just want to see place names and the epicenter. And the sprite sheet is just this. It's just 3 kilobytes. So yeah, static files, I think, can serve as a good proxy for tilesets. I'm talking about just loading GeoJSONs, images, and also videos, which I'll talk about after. So I stumbled upon this video. It was showing how Apple's able to create these like incredible scrolling experiences on their website to demonstrate new AirPods or whatever. But it really resonated with me because pretty much they're just creating a bunch of PNGs and pushing it onto an HTML canvas element, which is essentially what a web map is for the most part, like a Mapbox map or maplibre. So before starting at the New York Times, I wanted to become more familiar with Svelte and and also weather data, processing weather data, and I also wanted to experiment with this idea. So you can see as you start scrolling through this, you can see the network tab on the right is just processing all those PNGs as you're scrolling through, and it just is a really smooth way of loading a bunch of data very quickly, and it worked out being really performant on my end at least. And I think what makes this demo even better now is my access token is broken, so the base map's actually not there, so it's just the PNGs. And we've been using this at the New York Times with some of our hurricane mapping. We take a satellite image from goes east, goes west, and Himawari, and hourly we're trying to present what the storm looks like from above, and that's just a PNG. Last year I also did like a retrospective on the hurricane season, looking at rapid intensification, and I wanted to apply this idea of a tileset-less interactive web map that didn't rely on any third-party APIs and was just using images and GeoJSONs. Yeah, I'll show you sort of what elements are behind each of these here. So thanks to Natural Earth, I have this beautiful base map. I took the wind swath data for each of these storms, and we had been saving them over time so we could create that animation of the evolution of them. And this also allowed us to create like what the viewports would be for each of these storms. And then the sea surface temperature for the relevant times that contributed to the rapid intensification or didn't. The lines, and then the actual point data, some just for the frames of the animation, and the others are for the city labels. This is an experiment I did where I wanted to find just like a good drone video because I thought HTML5 videos, when they're on canvas, they're just like so smooth to interact with. And when you can leverage something like maplibre or Mapbox to zoom and pan, and turf.js to apply GIS on the fly, you can really get like a really smooth interaction with video that I haven't seen, really used too often. So yeah, I haven't done anything with this, but I just made this experiment, and I can share the links after. But yeah, it was fun tracing everybody on the court. Darren from Spark Geo also did like a cool experiment with this. He did like a full motion video blog post, and it looks so cool seeing this like aerial footage that's the frame is also changing its geography with each whatever second. But why am I here? Why did I do this to myself? Every year, we're trying to improve the hurricane tracker at the New York Times, and so we had come up with some visualizations of the actual track and where it's forecast to go. Like I said, we had these satellite images. We started supporting typhoons and international forecast precipitation, potential storm surge, but what we were really missing was this like CNN-style TV, live graphic, crazy colors of sort of where the storm is at any given moment, because usually you're reliant on the National Hurricane Center providing GIS data sets that come out sometimes at hourly intervals, but sometimes you're waiting 3 to 6 hours for an update of where the storm is. So I started experimenting with how can we get the live radar data in a performant and accessible way for readers. And I started tiling it, and this is like, I don't know, a lot of tiles. And I'm just like animating them, and it just was taking so long, and the tiles were so large, and it wasn't gonna be possible to use this style for something that we wanted to update every 5 minutes, every 10 minutes. So I opened this blog post from Vlad, the creator of Leaflet, and I probably do that once a year when I think I can do shaders or something like that. But I finally, I think, took something away this time I opened it up. I started looking at the source files, and these beautiful wind particle animations are essentially static files behind the scenes. It's like you have a PNG that's going from green to red, and you just have to interpolate between the green and redness. And Ricky Rouser, a developer at Mapbox, had been teasing out these new raster rendering capabilities that were super cool to see, and I was trying to think of how I could sort of integrate what I had learned from him and from that blog post to the radar imagery. And so this is what I ended up with. It's a 24-hour loop of just red band going from dark red to bright red that represents the level of precipitation intensity. And by using this new raster rendering capability, you're able to adjust the bands and the bins and the colors you want to use on the fly. So once you have that cleaned up red banded video on MP4, you can now have this like very clean file that it loads very, very quickly. Usually, like loads quicker than the tiles in the background, and it's just worked really well initially. So I knew this was the path to go down, and I broke things. Yeah, I was just playing with all sorts of color combinations. This is clearly the CNN version I'm trying to do here. Oh, and this is, okay. So that was the final thing, and then I also just wanted to make my entire presentation on a maplibre map and show you that static files are super quick and performant, and yes, that's my presentation.
Okay, so we can probably have 1 or 2 questions for William. If anyone has any questions, just raise your hand, and again, Nat will come to you.
Hi, first of all, I love the fact that your presentation was all weather related. I'm a meteorology nerd, hurricane nerd, so I follow all of that. I was curious when you were doing the wind swaths, you said you were collecting them, hourly. Were you manually going in and getting the National Hurricane Center's wind swath predictions or actual wind swath locations, or were you downloading that data from somewhere?
Yeah, we were downloading it from, I should repeat the question, right? You have a mic, so it's okay. Yeah, so we have some bots that we use to scrape data. So it's going to the National Hurricane Center and just grabbing it whenever the updates come through. And then so we're storing those with a timestamp, and then that's how we're able to go back in time and grab those best track wind swaths.
Okay, cool. Yeah, that would have been very helpful 10 years ago when I did my thesis. The bots. Thank you.
I think someone at the back.
One way in the back.
Yeah.
I'm so excited to see more people working with NexRad, like radar imagery, kind of outside the weather world, because it's so powerful and it's so informative. But at the same time, I've noticed, at least in internal conversations with graphics people who don't know as much about meteorology, that trying to describe that what radar data is showing is not exactly the same thing as just showing like rainfall in a very quantitative measure. Like, we're really talking about, like, I think decahertz and, radar waves bouncing back against particulate in the atmosphere rather than like rainfall rates. Have you had to like navigate those conversations internally and how you like communicate what radar values actually are to readers?
Yeah, I think that's a great question. Luckily, there's a meteorologist on the weather data team, Judson Jones, who's incredible for bouncing those sorts of questions off of. So we've had a lot of internal debates about sort of when those color breaks would occur, when it transitions from like a light blue to a dark blue to an orange. What are those colors supposed to represent? And I don't remember off the top of my head, but I remember like 60 hertz is when it's sort of, you're getting like higher intensity precipitation. So those are things that we went back and forth. And if you look at the legend, we try and it's like it's a gradient, but we only have 3 labels on it. So it's, light, heavy, and then extreme. So we try and, demonstrate that this is when precipitation will be intense, but not necessarily like it is going to occur 100% in this area. And we usually have follow-up maps as well, like observed rainfall and sort of how that happened over the last 24-hour period.